Hello everyone, and thank you for watching my video today. In this video, we're going to take a look at a little introduction to some basic probability. Before we get started, a couple keywords that we need to know. Sample space is a set of all possible outcomes, and an event is a subset of a sample space. Okay, so it's just one part of a sample space. So let's find the sample space for each of the following. First one, tossing one coin. What's this going to be? Either, we'll just say H for heads or T for tails. That's our sample space. Okay. Two events. Two coins are tossed. Well, it's either going to be HH, heads, heads, HT, heads, tails, TH, tails, heads, or TT, tails, tails. So that'd be four different events. Three coins are tossed. All right, so either it's going to be heads, 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 tails, heads, tails, tails, heads, tails, heads, tails, 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 heads, heads, tails, tails, heads, tails, heads, tails. Those are our 8 different events that could happen if 3 coins are tossed. Probability of an event happening. The probability of an event occurring is found by dividing an event by the sample space. Essentially, it is how many ways to achieve a certain outcome divided by all possible outcomes. All right, so number 1, 2 coins are tossed. What's the probability that both land heads up? What's the probability that one coin lands heads up and the other lands tails up? Okay, well, this is a pretty basic one to start with here. So probability of heads, heads, right? The probability of the first one being heads is 1/2. The probability of the second one being heads is 1/2. So then our probability is 1/4. Okay, what's the probability that we would get one coin heads up and the other one tails up? So that could be either heads, tails, or tails, heads, right? So the first one would be 1/2 times 1/2. Plus the second one would also be 1/2 times 1/2. So that's 1/4 plus 1/4, or 2/4, or 1/2. So the probability of getting one heads and one tails would be 1/2. What's the probability of getting a flush in poker? All 5 cards of the same suit. All right, so probability of a flush. So first of all, let's talk about all the possible hands we can get. There are 52 cards, and we're going to pick 5, right? So the denominator, all the possible events are 52, choose 5. To get a specific flush, we're going to have to first choose a suit. So there's 4 suits. We're going to choose one of them. And in that suit, there's 13 cards, and we're going to choose 5 of those. All right, so remember from yesterday, this is something you probably should have your calculator handy on. You can use the NCR abilities of the calculator to do all these. You can multiply them all together at once, or you can do them each individually. So we should get 4 times 1287 over 2598960. And if you do that correct, it's 0.00198 or 0.198% if you change it to a percent. Pretty small chance of getting a flush. What's the probability of getting a full house? So 2 of one type and 3 of another type. So probability of full house. So again, our denominator is all the sample space here. So that'd be 52, choose 5. Okay, so if we're going to get we're going to get 2 of one type and 3 of another type. So there are 13 different types of cards. So first we're going to choose a random one of those. So 13, choose 1. Okay, and then we're going to choose, we want to get 2 of those. So there's 4 of each one, so we're going to choose 2 of those. All right, so for the 13 choose 1, there's 13 different cards. So let's say we picked a 9. Okay, so we want to get 9s first. Now there's 4 9s. We're going to pick 2 of them. Okay, so that's where that comes into play. All right, and means we're going to multiply. So now there's 12 different cards. We're going to pick one of those. And again, there's 4 of them, and we want to pick 3 of those. Okay, so go ahead and put that all in your calculator. You can do this all as one and then divide it by this. You can do each one individually. It's totally up to you, but you should get, when you're done, 0.00144 or 0.144%. In the state lottery, a player chooses 6 different numbers from 1 to 40. If these 6 numbers match the 6 numbers drawn by the lottery commission in any order, the player wins the top prize. What's the probability of winning the top prize? All right, so probability of winning. The best way to do this would be to say, all right, I'm going to pick 6, and I need all 6 of those to be picked. So 6 choose 6 over the sample space here. So there are 40, and we're going to pick 6 of those. So 6 choose 6 is obviously 1. 40 choose 6 is 3838380. So the probability of that would be a very small number, 0.000000261, or 0.0000261%. So pretty small chance you're going to win the lottery. And that's only if there's 40 numbers. A lot of lotteries have 50 or 60 numbers in them. Next one, a bag contains 6 red, 6 green, 6 blue marbles. Each color contains the numbers 1 through 6 labeled on the marbles. So there's 18 marbles total. We're going to draw 3 marbles. What's the probability of getting all red? So probability of all red. All right, so that would be, there's 6 red. We're going to choose 3 of them. And the sample space would be 18. And we're going to choose 3 out of there. So that would be 20 out of 816. Convert that to a percent. 2.45%. Probability of getting at least 3 blues. So remember, that means the probability of 3 or 4 blue. So the probability of getting 3 blue would be 6 choose 3. And then there's 12 other colors, choose 1. Or means plus. The probability of getting all 4 blue would be, there's 6 of them, we're going to choose 4 of them. Divided by the sample space, which again is 18, choose 3. Take a minute to put that in your calculator if you need to. Okay, if we type all that into our calculator, and again, you could be doing it all at once, or you can be doing it one piece at a time. Either way, make sure you round to nearest hundredth of a percent here, and we should be getting about 8.33%. Question C, when drawing 3 marbles, what's the probability of getting 1 of each color? So probability of 1 red, 1 blue, and 1 green. And remember, it just says 1 of each. It doesn't matter what order. So order does not matter here. So we're using combinations. So it's going to be 6 choose 1 and, so multiplication, 6 choose 1 and 6 choose 1. All over sample space, 18 choose 3. Okay, and if you type that all into your calculator, you should be getting about 26.47%. D, when drawing 5 marbles, probability of getting all prime numbers. So prime numbers are 2, 3, and 5. Non-prime numbers then would be 1, 4, and 6. So probability of all prime. If 2, 3, and 5 are prime, and there's 3 of those, but 3 colors, that means there's 9 prime numbers. So we're going to say 9 prime numbers, choose 5 of those. And there are 18, choose 5 is our sample space. So that would give us 1.47%. E, drawing 3 marbles, probability of getting at most 3 blues. So that means 3 or 2 or 1 or 0. So probability of 0, 1, 2, or 3 blue. So remember, or means we add, right? So 3 would be 6, choose 3. 2 would be 6, choose 2, and then there's 12 others, choose 1. 1 blue would be 6, choose 1, and there's 12 others, choose 2. And then 0 blues would just be 12 others, choose 3. And again, our sample space is still 18, choose, in this case, 3. All right, so take your time with this one. Really take your time with this one. I think I just screwed up with my calculator. Let me try it again here. So 6, choose 3 is 20. I'm going to write this down one at a time here. So 20. 6, choose 2 times 12, choose 1 is 180. All right, 6, choose 1 times 12, choose 2 is 396. And then 12, choose 3 is 220. So 220 plus 396 plus 180 plus 20 would be 816 over 816, which is 1 or 100%, which makes sense. If we're drawing 3 marbles, the most we could get would be 3 blues. So that's why it's 100%. All right, number 6. 2 cards are drawn from a standard deck of cards. What's the probability at least one of them is an ace? So that means if we're drawing 2 cards, we can get probability of 1 or 2 aces. All right. So the probability of picking 1 ace would be 4, choose 1, and then 48, choose 1. Because there's 4 aces and 48 non-aces, or pick 1 of each. The probability of picking 2 aces would be 4, choose 2. And then there's 52 cards in a deck. We're choosing 2 of them. That's our sample space. All right, go ahead and type those in, 192 and 6. All right, and we rounded to about 14.93%. Probability that 1 is the queen of hearts and the other is another heart. All right, so probability of the queen of hearts plus another heart. Okay, the probability that we get the queen of hearts would just be 1, choose 1, because there's only 1 of those. And then the probability that we choose another heart would be, there's 12 left, choose 1 of those. Multiplying because it's and our sample space is still 52, and we're choosing 2. So we get that, and we should be getting 0.90%, less than 1% of that happening, chance of that happening. 2 6-sided dice are tossed. What's the probability that the total of the 2 dice is 7? Okay, so first of all, let's figure out how many different possibilities there are. This is not really a good combination type problem. Let's just try to figure this out. So probability that the sum is 7. If there's 2 dice that both have 6 sides on them, and you roll them both, how many different possibilities could we have of matching up? So there's 6 and 6, that's 6 times 6, that means there's 36 different possible rolls we can have, okay? The probability of the dice is 7. Well, let's think about this for a second. We can have 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, or 6 and 1. So there's 6 different possibilities, so it's 6 out of 36, or 1/6, or 16.67%. What's the probability that the total of the 2 dice is at least 5? So that means the probability of getting 5 or 6 or 7 or 8 or 9 or 10 or 11 or 12. All right, so again, there's 36 different possible combinations we could get. Let's figure out how many times we can get 5, 6, 7, 8, 9, 10, 11, or 12. Okay, so maybe our best option here is to make a little table here. First dice can be 1, 2, 3, 4, 5, 6. Second dice can be 1, 2, 3, 4, 5, 6. So 1 and 1 is 2, 3, 4, 5, 6, 7. Next row, 2 plus 1 is 3, 2 plus 2 is 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, and 7, 8, 9, 10, 11, 12. All right, so the cutoff is right about there. All right, it might be easier to think of it this way. There are 6 possible ways to not get a 5 or higher, which means our probability would be 30 out of 36, which is 83.33%. So if you roll 2 dice, there's an 83% chance you'll get at least a 5 sum. All right, last one here. At a wedding, the DJ has a list of 10 songs left to play, but only has time for 6 more. A guest has 4 songs in mind that he really wants to hear before leaving. What's probability the final playlist includes all 4 of them? So probability of all 4 songs being played. All right, our sample space, well, there's 10 songs, and we're going to choose 6 of them. All right? Probability that the 4 that they pick that they want to be played happens. So he wants 4 and choose all 4. And then there's 6 other ones, and we're going to pick 2 of those. The probability that that is going to happen. Put that in your calculator, and you should get 7.14%. Okay? All right, that will do it for our introduction to probability. We'll see you again next time.